In this video, I'll be covering what placement criteria is and how to use it. On a socket, you can configure which item types can be socketed by using the Allowed Tag section. Although a good start, this doesn't provide the granular control you may need in your project. This is where placement criteria comes in. Placement criteria is a way of preventing an item from being placed until all of the requirements have been met. You can add placement criteria to a socket which will apply to any object you try to place in that socket, or just the placeable item, which will apply the criteria to any socket that that item gets close to. In this guide, we'll be taking a look at the placement criteria that ship with this asset, and then we'll be taking a look at how to create your own placement criteria. I've got a simple demo scene set up. I have a backpack with 5 sockets. I also have a couple of placeable items. The 3D models are third-party assets, and you can check out the quick start guide if you need any help setting up your sockets and placeable items. Let's start by taking a look at the placement criteria tab on the socket. As you can see, the format of this tab is similar to the highlighter tab, with a list of components that you can add at the top, followed by a list of the active components you have added. You can easily add criteria by clicking the Add button, and you can remove them just as easily by using the Remove button. The socket has one built-in criteria, the Not Holding Item criteria. This component prevents the placement of an item while it's being held. If this socket didn't have this criteria attached, then as soon as the item entered the placeable range, the item would instantly be socketed. Most of the time, this probably isn't what you want. Instead, by preventing the placement while the user is holding the item, it allows you to highlight the socket, perhaps with a hologram, and allow the user to confirm they want to place the object in the socket by letting go of it. Now, if you take a look at the component, you'll see it has 2 exposed properties: Should Use criteria and Prevent highlight. These properties can be set in the editor or via code. These properties will be present on all placement criteria as they are part of the criteria interface, which you'll see later on. The Should Use criteria just toggles if the criteria should be used or not, and the Prevent highlight determines whether or not the criteria should prevent the socket from highlighting. Let me explain. Sometimes you may want to highlight a socket even if the item isn't technically placeable. The Not Holding Item is a great example of this. When the item enters the placeable range, we don't want the item to be socketed right away because, as I just mentioned, we want to wait for the user to release the object to confirm they want to socket the item. However, when we're holding the item, the Not Holding Item criteria is not met and will return false, meaning the item is seen as unplaceable, which will prevent the socket from highlighting. So that's why there is this Prevent highlighter option, so you can tell the socket to highlight even when this criteria hasn't been met. This allows you to create highlighters that will display when an item is in the placeable area but isn't placeable. You could use this to change the effect of that highlighter based on if the item is actually placeable or not. An example of this could be when a user tries to place a large item into a small inventory slot. You may still want to highlight the slot to show that the socket recognizes the item is within placeable range, but you could turn the slot red to indicate the item isn't allowed in this specific slot. We'll see this in action when we implement the inventory slot criteria. Before we get to that, let's check out the placement criteria tab on the placeable item. It's very similar to the placement criteria area on the socket, apart from these criteria will be used on any socket this item gets near to. We've already seen the Not Holding Item criteria, but the placeable item also has the Resocket Cooldown Pass criteria. This criteria won't allow the item to be resocketed until a cooldown has passed, handy for when you grab an item out of a socket and don't want the socket to instantly highlight again. This leads us on to our example. I'll now show you how you can create your own placement criteria. We'll create an inventory slot criteria that only allows items of a specified size into the slot. We'll also display the slot as red when an item is too big for that slot. As this criteria is for an inventory slot, we'll be applying the criteria to the socket, not the placeable item. Let's get started. So the first thing we're going to do is create an inventory item script. This script is going to be responsible for assigning a size to an item. For the purpose of this guide, it's going to be very simple. We'll just have a single public property that will be the item size. Now, let's assign this component to the game objects we want to make inventory items. Let's give all of the objects a size of 1, except the sword, which will have a size of 2. Now, onto the placement criteria. Let's create another script called inventory placement criteria. Let's jump into the code. The first thing we want to do is create a serialized property to dictate the size of this inventory slot. Let's call it slot size and give it a default of 1. Now, let's implement the placement criteria interface to turn this component into a socket criteria component. The interface is called iSocket placement criteria. Make sure you add the required namespaces. If we wanted to make criteria for the placeable item instead of the socket, you'd use the iPlaceable item placement criteria interface instead. The placement criteria interface has 4 functions that you'll need to implement, but don't worry, they're all quite simple. The setup function is called when the criteria is added to the socket. It passes in a reference to the socket, allowing you to cache a reference to it. This is so you can use it later in other functions. For this example, we won't cache it, although if you do, remember to make the socket property a serialized field. The reason you need to do this is because the setup function is called in the editor outside of play mode, which means the reference won't persist unless it's a serialized field. As I mentioned before, you can choose for the criteria to prevent highlighters. In this case, we want to highlight the socket in some way, even if the inventory item is too big for the slots. So we'll make the prevent highlight function return false. Next is the use criteria function. We want to always use this, so we'll simply return true. Of course, in your own project, you can set this dynamically at runtime based on your use case. Last but not least is the canPlace function. This function is where you write the main logic of the criteria. For this example, we need to check if the item size is less than or equal to the slot size of this socket. So we'll need a reference to the inventory item component we assigned to those game objects a minute ago. Conveniently, we have a reference to the placeable item as it's passed into the function, allowing us to access the root transform of the item, which is where we attached the inventory item component. Let's just add a check to make sure we have a reference. And finally, let's compare the size and return if the item size of the inventory item is less than or equal to the size of the slot. Okay, perfect. That's all there is to it. In your use case, you could do whatever you like in the canPlace function. You could call a singleton, or you could use a reference to the socket to determine if the item is placeable in your use case. Let's go back to the editor. When you go to the Placement Criteria tab, the new criteria is now showing in the list. Let's add it to all the slots. The default slot size is 1, so we only need to change the slot size on the side slot. As this slot is larger, we'll give it a size of 2. We've done this so all the items on the front of the backpack will accept an item with a size of 1 or less, and the side slot will accept an item of size 2 or less. Now, let's add some highlighters to these sockets so we know when an item is close to the socket. I'm going to add the socket color controller and the socket sprite scaler. I'll set the placeable color to white, but leave the unplaceable color as red. Once again, because I set the inventory slot criteria to not prevent highlighters, we'll see the sockets react to the placeable item entering the placeable area, even if they are not allowed to be placed. Let's test out our inventory system. So first I'll try to place the money bag. I should be able to place this in any slot because the size of this item is only 1. Okay, great. All of the sockets are accepting this item. Next, I'll try to place the sword. Because this item has a size of 2, it isn't allowed in the front slots. Let's see how this looks. Perfect. The front slots prevent the placement of the item and indicate this by scaling down and turning red. But when I try to place it in the side slot, the socket indicates it's placeable and allows me to socket the item. Fantastic. That inventory criteria was really easy to implement. One thing to remember, if you have multiple criteria on the socket, or even some criteria on the socket and some on the placeable item, placement won't be valid unless all of the criteria is met. I hope this guide has helped explain the placement criteria section of the socket system. As always, if you have any questions, please get in touch via the Discord or the support email, which are linked in the video description. Thank you for watching.